Hi, my name is Aerin, and I'm the founder of the resume board BOR. And today I'm going to talk about deep NLP essentials. It's deep NLP because it's about deep learning, and we're going to deep dive today. First of all, thank you for attending my talk, even though there are lots of great speakers in my time slot. I feel honored to be at this conference with the people that I admire, like Dr. Yoshua Bengio, Dr. Ian Goodfellow, and Sam Altman, etc. By the way, lots of people think that word embedding is a new concept, but Dr. Bengio was the first person who applied neural networks on language model in 2003. It's not 2013, so it has been 15 years. Anyways, I want this talk to be useful to you, so because you tuned in. So what I'm going to do is I'm going to go over the questions that I had while I was building NLP apps and the resources that I referred to and some very useful Stack Overflow questions. I think that will be helpful. And the audience who will benefit the most from this talk, I think the audience who would benefit the most from this talk would be the people who are building NLP app or students who are taking natural language processing class at this moment. And I think the next 30 minutes will be interesting supplement to their original coursework. And instead of holding all your questions until the end, if you have a question in the middle, feel free to type it. I'll be happy to answer any question. So let me tell you about the startup that I'm working on. It is called BOR, Build Your Own Resume, and it's an NLP startup. And this is what you see when you upload your resume on BOR. So the yellow block here wrote SQL queries to import large data set from SQL Server, depending on the needs of different departments. This is what the user wrote. And we tell the user that your sentence looks weak. It's missing a result phrase. Ouch. So here, the result phrase means that the phrase that describes a tangible result or your accomplishment. And we give user the phrases that he can use, like that helps you to store and manage your data in a safer manner, or minimizing the redundancies, or resulting in substantial reduction in query. And the user can rate these suggestions by clicking this good, so-so, wrong buttons. And we have been gathering this data set since last September, and we have about 11,000 data set. And this data is what we use to make our algorithm to do a better job every day. And how do we do this? So to detect whether or not the sentence has a result phrase, we use PCFG parser to detect that. And if the result phrase is missing, we match the original sentence that user wrote with result phrases in our database. And we use word embedding to do that matching. So the phrases that you see is, they are pre-written phrases. And I know many people are very excited about generative model, but BOR uses a retrieval model. And we do keep experimenting with generative models. And that's why we first select our domain as resume domain, a very narrow domain. But it's still hard not to make any grammatical mistake using generative model. And we do not manually screen the phrases before we return them to users. So sometimes it says irrelevant things. But other big companies like Microsoft or Facebook do screening their chatbot's response before they return anything to users. And I asked Dr. Yanli Kun of Facebook at Baylearn if Facebook screens every single response to user in Project M, and his answer was yes. So screening is a reasonable thing to do in Chatbot 2017. Most frequently asked question in Stack Overflow NLP is there an algorithm that tells the semantic similarity of two phrases? And this question was asked in 2008. So it has been 10 years, and it has many linked questions So people keep asking similar questions, and this question is viewed like 30,000 times and always active. People keep posting answers. And they suggested many different ideas, like maybe we can use synset or wordnet or like weighted average of words. But in 2017, to compare the semantic similarity of two sentences, I think using the word embedding is the most effective way to go. And we built this together in my previous talk and with the best. And what we did was very simple. First, we downloaded the pre-trained vector and we averaged each word vector in the sentence. Then we got two different phrase vectors or sentence vectors, and we calculated cosine distance of them to measure how similar these two phrases are. So for people who missed my last talk, let's quickly review what we did. So this is the phrase similarity calculator, and you can download it from my GitHub. Type the phrase 1. America's airlines are shameless, but United has just set a new low. Phrase 2 would be United Airlines has a history of bad customer service. The similarity score is 68%, so it's pretty similar. United Airlines is still begging for your forgiveness. United Airlines recognizes it can never apologize enough. And those two sentences are 70% similar. Isn't this great? And United Airlines has a history of a bad customer service. Fly the friendly skies. And of course, it has like low similarity score. And the way we did this is this very simple Python file. So we just read the pre-trained vector, and we only use NumPy and math and SciPy. And the cosine similarity is just a one line, NumPy dot product and linear algebra. So you might think that the idea of simply averaging the word vectors in the sentence might be too simple, but it can take you pretty far, especially when you're building your first chatbot. And actually, this was the tip that I got from Kwok Lee, the pioneer of deep learning, when I was building my first chatbot. He said, if you cannot retrieve the hidden states, just average the vectors. And that's what I did. And there are other ways to make phrase vectors. And one is to train the TensorFlow to do the machine translation and then retrieve the hidden states. That's more advanced way to do this. Okay, let me go back to this slide again. So they are the pre-trained vectors that you can download and test. So we just used word2vec train vector on Google News Corpus, and it has 300 dimensions, and it used negative samplings. You can download it from here. And another interesting method is Glove. It's pretty similar to word2vec. And I like Glove because it gives you the full spectrum of dimensions and training corpus. So it gives 50 dimension, 100, 200, 300 dimension vectors. And also it gives you different vectors trained on different corpus like Wikipedia, Common Crawl, and Twitter. Another interesting question is, where do dimensions in word2vec come from? I used to have like exactly same question when I first saw word2vec. So he's saying, I am using word2vec model for training a neural network, blah, blah, blah. Let's say we want to display book, paper, notebook, novel words on a graph. First, we all should build a matrix with dimensions 4x2, 4x3. I know the first dimension of this matrix is the size of our vocabulary V. So he got this right. But the second dimension of this matrix, like 0.3, 0.1, 0.04, what are these numbers? Do they have any meaning? Is it something like TF-IDF, or is it something like co-occurrence matrices? So basically, he is confused with co-occurrence matrix with the weight matrix. So co-occurrence matrix is this. Co-occurrence matrix is it has the same number of columns and the same number of rows. So it's a square matrix, and the number of columns and number of rows is number of vocabulary. So we built this matrix by counting adjacent words together with the sliding window size of 1, and we built this together for my previous talk. So let's say there's 3 sentences, and they are those are our culprits. President Trump has many buildings. Trump owns many factories in China. So the way we build this is count the co-occurrence. President Trump has many buildings. So in this many building case, we find the many here and the building here and put 1 by it. So increment 1 by 1. So then what is this W that he's asking? So when you open the Word2Vec file, what are those numbers, like 0.8, 7, 6? These numbers are not the count of how many times those words appeared. They are the parameters that are optimized by gradient descent. And the number of columns in that embedding is not the number of vocabularies. They are predefined number by your choice. So the following question would be, do these dimensions have any meaning? So it's very rare to find the single dimension by itself has a meaning, like this dimension is a noun, this dimension is subjective, something like that. But we could find meaning through multiple dimensions, like combining 16 dimensions or 20 dimensions. We could find something like words in that entire space are adverbs, or this entire space is not nouns, etc. And you can test this yourself. And if you find something interesting, please let people know. They will be very, very excited. So after we build this co-occurrence matrix, we applied SVD, right? But why do we apply SVD? Because we don't want to use huge co-occurrence matrix like 1 million by 1 million matrix, which is also very sparse. And we want to reduce the dimension of that matrix without losing too much information. So for example, here is 2D graph, 2D data. And if you want to reduce the dimension of this 2D graph into 1, what would you do? We can just project this on the x-axis here. But the better way to do this is to draw the axis along the data so that we can keep its original distribution as much as possible. And then the following question would be, how many columns in U should we choose? So when we apply SVD on X, it returns U and SMV. And we usually select the first 2 columns of U when we want to project the data in 2D space. But when we don't want to, or when we don't need to project it on 2D space, what is the optimal K value to choose? If you select the first K columns of U, that means you're reducing your original N dimension to K dimension. So you need to cut them off at some index K based on percentage variance that is captured. And we are going to use eigen components in vector S here. And it has the measure of its importance, which is singular values. So let's say the first 3 eigenvalues have cumulative percentage variance explained of like 99% by using this equation. Then it's safe to use the first 3 columns. Okay, and so let's talk about evaluation. How we are going to test these word embeddings. Word2Vec is an unsupervised task, so there's no best way to objectively evaluate your output unless you define the object. So evaluation depends on your end application, but there is one way to evaluate embedding, and that is to test the analogy. So here's famous example like queen, king, woman, man. And what we are going to do is we assign each variable here, so 4 different variable A, B, C, D, and we'll subtract vector A from vector B and add vector C there. Then we will have just one vector. And then we will loop through all keys in our dictionary, every vocabulary in our pre-trained vector, and then return the closest vector. And then if that vector matches the word D, like in this case, man, then we mark that test as successful. Google released their syntactic and semantic testing data set here, and you can download it from here. They are about like 20,000 pairs. So semantic test would be boy, girl, dad, mom, and honest, dishonest, unknown, known, unknown, and USA dollar, Europe, euro. So they are the semantic test set, and the syntactic test set would be amazing, amazingly, calmly. And one thing to remember here is good performance on this test set doesn't mean that your trained vector will perform well in your application. So it's always better to evaluate the vector on your own task, unless you're using supervised learning and training your vectors on the objective function of your own task. So for unsupervised vectors, we are going to BYOT, build your own test set. I think I just like this BYO too much. And here are the test sets that we have built so far. So Zuckerberg, Bezos, Facebook, Amazon, Cellini, Puccini, Sculpture, Opera. And this test data set, the blue one, you can test and see for yourself as well, because it passes on what publicly available pre-trained vector set. So, and I tested on like globe vector, 50 dimension, not even 300 dimension. So even if it's very low dimension, it's still very obvious to that pre-trained vector that the Amazon and Opera is related to Zuckerberg and Bezos. And again, this is not machine learning finally understand everything and about to outsmart us. Very simply, this is statistical co-occurrence captured, because those names, Zuckerberg and Bezos, they are very frequently appeared with founded or announced a new product with a company name. So if you collect these sentences with the right window size, this is not impossible. And we are recruitment bot or resume bot, so we build this test set of lots of technical keywords like SVM, K-means, MySQL, MongoDB. And for shopping bot, we can build test set like Rolex, Hermes, like using the brand name and its items. And do you know what corpus performs the best in analogy testing? It's Wikipedia trained vectors, because it contains lots of new information. And Wikipedia trained vector performs better than news article vectors, at least in analogy testing. Okay, this is our last question. Why do we need bigger vector space for displaying relations in word embedding models? So he's asking, why should we use, let's say, 100 hidden neurons for our hidden layer? Why not 300 or 10? So 300 is empirically chosen number. After we trained the corpus, we found out that having same corpus, having same method, 300 dimension is much more accurate than 10 or 50 dimension because it has more degrees of freedom to capture the relationships that you're after. So if you look at the graph on the left, by the way, these graphs and numbers are from the paper Global Vectors for Word Representation by Dr. Sosha and Dr. Manning. So 50 dimension, so x-axis is vector dimension and y-axis is accuracy. So on 50 dimension, it loses too much information. And as you increase the dimension, accuracy increases as well. But if you keep increasing the dimension to, let's say, thousands, it keeps too much noise and the accuracy starts declining. And same goes to window size. If you capture too many words to the left and to the right, the accuracy declines. So if you see the green line is semantic and the purple line is syntactic, the syntactic goes down, but interesting thing is the semantic accuracy goes up because the more you capture, the more context, the more information you would have. But there's always a trade-off. When you increase the window size, it takes longer time to train. And same for vector dimension. It takes much longer to train 300-dimensional vector than training 100-dimensional vector. And what else is also effective in improving the accuracy, other than the vector size? Is increasing the size of the training corpus. You would get about 70% accuracy if you train the model with 1 billion tokens. But if you increase the size of your training data to 40 billion tokens, you can improve the performance to 75%. And these numbers are also from the Globe paper. So until this slide, I praised how great the word vectors are and how you can use it on your app. But I'd also like to mention its challenges. So for example, if we test the similarity between increase and decrease, it says it's 83% similar. And if we test the exited and entered, it says 61% similar. Why is this happening? Why antonyms are, why are they so close in this space? Because most of opposing ideas have similar context. For example, they increased the price, or they decreased the price, or she exited the building, or she entered the building. So words close in the space are synonyms like bright and shining, but also antonyms and other easily interchangeable words like yellow or blue. They are close in the space too. So what can we do about this? So if you Google it, some approaches have been suggested, but they are limited in some ways. For example, they require words to occur in certain patterns, or they rely on these sources, etc. But last night, my TA gave me this paper here while I was preparing this talk. I'm taking NLP class at UW these days, and they proposed to inject antonym-related or synonym-related constraints into vector space in order to fix this. So if you're interested in this, take a look. And if you can find a smart way to do this, I think it will be great, and you can publish it on distill.pub. What is essential in deep NLP? I think linear algebra is essential. So if you're looking for good resources for linear algebra, I recommend the lectures by Dr. Strang. And this video is recorded in 2005, so it's pretty old, but it's a classic. It's really good video. And I think success in any arena is always about fundamentals. So neural network is applied math, is matrix math. So we apply chains of matrix operations with nonlinear function. Then we optimize it to minimize the loss. And all those computations are in matrix form. So if you understand multi-dimension vectors very well, it will definitely help you to build up better applications. So thank you for listening. And we created a short video using just rotation metrics and lines. So if you're interested in applied math, please check this out. And I'll go to the question and answer. Did you have a look at Facebook fast text? Stephen Mayer. No, I haven't. Thanks, great talk. Have you trained RNNs yet? We did, but the result is not as good as using our current model. What tip do you have for new developers in NLP? Have you looked at Textio.com? Yes, I have. They are based in Seattle, and it has female founder. Yeah, I have looked at Textio, and the new tips for tips for new developers in NLP. I gave the tip on the AI with the best interview, saying give the what? Have you guys checked out the Dex? He's a YouTube lecturer. So if you're new in NLP, Excel, check out the Dex, SENTDEX. His video. He's really useful. Where can download financial news corpus? Thanks. Lion Cheney. I don't know where you can download the financial news corpus. Maybe Bloomberg or AP News. Just Google it. Okay. Yes, Aerin. That's Syntax. So what other messages we have? Do you think will be? Oh, Wayne, we is not built on 11K resumes. So Wayne asked, you mentioned that yours was built with 11K resumes. What do you think would be the lowest number of resume model could be built off of? So I think I wasn't clear to you. So we are not built on 11K resumes. The people who click the good, so bad button, those data set is 11,000. So normally when you have the lowest number that you can build the well working model I would say 1 million at least. And it doesn't need to be 1 million resumes, but at least 1 million sentences. You can try with 100K sentences, but like it's safe to have 11K. I mean 1 million sentences. Can we have the link to your GitHub, please? Yes, I will give it to you right now. It's actually not GitHub, it's Bitbucket. It's this one. And you can always ping me if you need anything else. And the slide video will be, yes, it will be available. How sophisticated an NLP algorithm can be with open sourcing for a small team compared with ones from companies like. Yes, overcode. So that's what I do. So we're basically, I am the only full-time founder and we have 3 other people working on this, but I don't know how I could compete with them, but that's what I'm trying to do. And how sophisticated NLP AI algorithm can be. But I think like if you have 3 or 4 NLP data scientists or NLP engineer who is working on the model itself, I think that's good enough. Maybe you would have some limitation on label data because label data is expensive. But like unsupervised model, there are lots of free text training corpus like Wikipedia or Common Crawl or Twitter data. Yeah. Where do we ping you? Slack? Oh, you can email me. My email address is dyor@dyor.xyz. What is your thoughts on video resume? What is video resume? People record themselves, like explaining what they did. Okay. I don't, no one ever sent me video resume, and I don't think HR people have time to watch your video, frankly. Did you ever have a look at Spacey? Yes, I have. You know what? Actually, Spacey has been in this space for a long time, and I spotted him like 3 years ago, and that time, it wasn't this popular, and I knew that he's going to be popular because it was such a high quality. And the Spacey, the guy, I forgot his name, but the one guy built the whole thing. So Spacey, yes, I have looked, and it's great API. Any good online classes you recommend? So I like Syntax a lot, and you know who I like as much as Syntax? Siraj. Have you guys checked out Siraj? Siraj is actually talking at this conference. I think he talked yesterday. Yeah, Siraj is really good. And Siraj is I think he's teaching deep learning in Udacity. Yeah, he's awesome. And so check out Siraj and Syntax, and but you know what? People ask lots of questions like which video should I watch, and when I tell them to watch Dr. Strength's linear algebra, they are not too happy. But like watch that video as well. It's really good. And again, it's matrix math. So if you have strong foundation on linear algebra, it will really help you. Oh, do you prefer TensorFlow, Theano, or something else? And if you guys, I just started looking at TensorFlow like a month ago, and the TensorFlow, I didn't like it too much because my all my code base is written in NumPy. So I had to translate this TensorFlow syntax to NumPy syntax, and that was pretty hard for me. So if you also want the I had this like small tutorial made it. So comparing NumPy syntax and TensorFlow syntax, I can give it to you, Wayne. Yeah, TensorFlow is evolving really fast, so that's why I didn't want to look at it, but I looked at it, because if you don't learn in this space, you will get extinct. Also look into Cafe 2, just released in April. Okay. That is what Siri was using until. I never used PyTorch, Lion Cheney. Can we have your email address? Yes, dyor@dyor.xyz. Keras is easier to code and uses TensorFlow Theano at the backend. How much of dev time is invested on AI specifics, design, the neural network, how much on other tests like developing interfaces? And so I start building this since 2015 winter. So those like developing this suggestion model and like training the vectors, it took good 6 months. That was not even that was not even before. That is before launch. We launched last September. So those AI model wise, like good 6 months was invested. And while I was building, I learned a lot. So I asked all my questions to all those people. Like I went to class and asked people, to professors and like TAs and everyone. And other tasks like developing interface. So for our web development, it took like less than one month, yeah, 4 weeks. And what is SOL solution? Our website is not that, it's like really minimum viable website. Which university program is good for artificial intelligence? Yes, Rohit, Stanford is of course the best, but it's very hard to get in. So here's my last word. Yes. And also, like, people ask me questions like, where should we, I do not have degree, what should I do? And which class should I attend? Like, which school should I enroll? Like, and should I take a leave for my current work and stuff? But I started building this NLP apps like only for the past 3 years, and before that I didn't really work on NLP, and I never took any NLP class officially. Like, that means I didn't go to school for NLP. I studied applied math, but it wasn't like, I didn't take any NLP class in the school. But then still, you should not limit yourself by telling you, I did not have any official education, or I never took the class. So that is not the requirement for you to build anything. Then, like, because this machine learning is like, it started like what, 3 years ago? This hype started 3 years ago. So whoever studied CS like before 2014, they never took any class like this, but they are the people who are still building. So don't limit yourself that you do not have education. What you need is the your will to keep learning, and that learning can be done by online. And you can go to seminar and conference, and you can talk to people there. And this deep learning or AI community people are super friendly, because we know that we are on this bleeding edge technology. So they want you to actually work on some product problems that was never touched by other people. What are you working on before BR? You know what? I was working in a bank. I was selling derivatives, the FX derivatives at bank. Standard Chartered Bank. It has a big operation in Asia. Okay, then I guess this is the end of my talk, and thank you guys for engaging with me, and I hope this helped you. Bye.